In this video, we will be introducing vectors. As Rex sits in his backyard on a hot summer day, he begins to dream of chewing his bone. However, he is not exactly sure where he buried it. Fortunately, Rex made a treasure map, so he will be able to locate his bone. Here is the map. If you look closely, you might notice that something seems a bit off. While the map gives the number of steps, Rex didn't write down any directions. This means that the bone could be almost anywhere in the yard. Fortunately, Rex realized his mistake and redid it. Here is his new map. Rex used north, south, east, and west for his directions. Rex will begin at the bottom of the stairs and then walk 6 steps west. The second line says to walk 5 steps north. The third line on the map is to walk 8 steps east. Next, Rex will walk 3 steps north. The fifth line tells us to take another 4 steps east, and lastly, the final line is 2 steps south. Now Rex digs up his bone and his dream has become a reality. Each of the 6 lines on the treasure map is a vector. From this example, we can learn a few key principles. The first is that vectors must have both a magnitude and a direction. In this case, the number of steps is the magnitude, and the direction is north, south, east, or west. Longer arrows represent a larger magnitude or value. The second principle is that vectors are always added head to tail. The head is the arrow, and the tail is the opposite end. The tail is where we begin, and the head is where the vector ends. The third principle is that vectors can be added in any order. In this example, the first 2 directions were 6 steps west, followed by 5 steps north. If we swap them, we will go 5 steps north, followed by 6 steps west. As you can see, we end up in the same location, regardless of the order. The fourth and most important principle is that vector components can be added and subtracted. Vector components are the part of a vector that is solely along one axis. For this example, we will now add all of the vector components together. If you look at the map, there are 4 directions: north, south, east, and west. However, there are really only 2 axes. North and south are opposites, as are east and west. In math or physics terms, east-west is the x-axis, and north-south is the y-axis. Steps along the same axis can be added or subtracted. If you take 2 steps to the left and then 2 steps to the right, your overall movement is 0. Without realizing it, you are adding vectors. However, walking 2 steps forward cannot be combined with steps left or right. In this example, all the vectors are entirely along one axis, so they are already components. The first thing we will do is highlight the directions on the map in each color. East and west will be blue, and north and south will be red. Since they are east and west, we will highlight 6 steps west, 8 steps east, and 4 steps east in blue. We will now highlight 5 steps north, 3 steps north, and 2 steps south in red. Next, we will add the steps along each axis. In this example, 6 steps west and 8 steps east is the same as 2 steps east. If we now add in the 4 steps east, the treasure map totals 6 steps east. We can do the same thing in north and south direction. We begin by going 5 steps north and then 3 steps north. Added together, we get 8 steps north. We then take 2 steps south, so we subtract 2 steps, and the total is 6 steps north. If we start at the deck and walk 6 steps north, followed by 6 steps east, we end up in the same location as we did when we followed the treasure map, but in a more direct and efficient route. In the next video, we will discuss vectors that do not go nicely along one axis. If you found this video helpful, please click on the like and subscribe buttons below or visit us at rexwellphysics.com. Thank you and have a nice day. Bye!